Today, we will be discussing about properties of light. My name is Ray Valencia. Here are the objectives of this lesson. To understand how light travels and describe how it is reflected, and to experiment with flashlights, mirrors, and random objects. We can see objects around us because light from them enters our eyes. Without light, we cannot see at all. Our main source of light is the sun. The sun radiates light and heat through the space to us. Light and heat are forms of energy that we need to survive. Without the radiation from the sun, life on Earth would not be possible. Here are the properties of light. Light is a form of energy. Light energy can be changed into heat, electricity, and other forms of energy. Light travels extremely fast. The speed of light in vacuum is 300,000 kilometers per second, or 3.0 times 10 to the power of 8 meter speed. With this speed, it takes 1.3 seconds to travel from the moon to the earth and about 8 minutes from the sun to the earth. Light travels on straight lines within the same medium or material. When light hits the surface, it can be reflected. When light travels from one media to another, the straight line on which the light travels makes a key. This property is called refraction of light. A straight line in which light travels is called light ray. Usually, light does not travel on a single ray, but on a bundle of rays called beam. We can distinguish between parallel beams, diverging beam or divergent beam of light, and convergent beam of light. Most objects do not produce light of their own. They reflect the light that falls on them, and our eyes see the reflected light. So the color of an object depends on the color of light, and that is reflects back into our eyes. The colors we see depend on the sort of light that falls on objects. Yellow sodium street light makes some colors very bright. As you can see in the pictures, there are different colors reflected through the medium of water. All right. We can see objects around us because the light that is reflected by them hits our eyes. The direction and amount of the reflected light rays depend on the nature of the surface of the object. When the parallel beam hits a very smooth surface, the reflected beam also parallel. This is why we called it regular reflection. This figure is called regular reflection. All right. It happens when objects like glass, mirrors, or polished metals, sharp images are produced. When a surface reflects all incident light rays regularly, that is the reason why we can see our image in mirrors or other very smooth surfaces. All right. But when a parallel beam hits objects that have rough surfaces like paper, cloth, or wood, light is reflected in different direction. This is called diffuse reflection. All right? In refraction of light, light can pass through transparent media or materials like mirror, glass of water, or some kinds of plastic. However, the speed of light is lower in these kinds of media or medium or material than in the air. Thus, light slows down when it passes through the surface of water or glass. The change in the speed of light causes the straight line on which the light travels to make a kink, and the light's ray is bent, and this is called refraction. All right. Light can pass through, right? Transparent media light. So in this figure that you can see right now, this is the sample of how do we see the figure inside the water, right? The light slows down. And then there's a changes of speed of light, causes the straight line on, which travels to make the kink. And the light ray is bent. And this is what we call the refraction. All right. The transparent medium is characterized by an index of refraction, or letter N, which is defined by the ratio of the speed of light in vacuum, or letter C, to the speed in the medium or material, which is letter V. All right. Now, so we have this index of refraction, which is equals to speed of light in vacuum and over in the speed in the medium or material. Okay. And now this is our formula. N equals letter C over V. Note, the value of N should be always more than 1. All right. When light travels from a less dense media, it is fast. Like air in a denser media, slow. Like water or glass, the light bends towards the normal. All right, as you can see here, the less dense medium, then denser medium. All right, the light bends toward the normal. This is the normal. We see this is the straight line. So the light travels from here, less dense, all right, and then with the material of water or glass, then the light bends toward the normal. All right. When light travels from a denser medium, slow, to a less dense medium, fast, the lights are bent away from a normal. As you can see here, all right, the lights travel from a denser medium, which is slow, to a less dense medium, which is fast. Then the lights, this is the normal, all right? And then the lights are bent away from the normal, which is away from the normal. All right, next. When light hits the surface of a transparent medium parallel to its normal, then the light passes through the surface on a straight line. In this case, no bend and no refraction occurs. As you can see here, right, when the light hits the surface of a transparent medium parallel to its normal, right, transparent, like, or maybe this clear glass, then the light passes through the surface of a straight line, okay? In this case, as you can see, no bend, okay? No bend and no bending away. No bend and no refraction occurs. All right. We apply the laws of the refraction of light in all of our optical devices like cameras, magnifying glasses, binoculars, or spectacles. Without refraction of light, we could not see at all, because our eyes also make use of the effect of refraction to produce images on the retina. All right. Given the indices of refraction of different media, we have here the materials or medium, air, water, and glass, with the equivalent index of refraction. Air 1.0, water 1.3, glass 2.4. All right. Again, like what we have seen earlier, we have this index of refraction, which is equals to speed of light in vacuum and speed in the medium or material. All right, this is our formula, and equals C over V. This is the standard equivalent or number for speed of light in vacuum, which is 300,000 kilometers per second, or 3.0 by 10 to the power of 8 meter speed. Now, we need to find out what is the equivalent or the index of refraction in the speed in the medium or material. The next would be the video of how to find out the speed in the medium of water. Of index of refraction, we have N equals C over V. N equals to, or stands for index of refraction. C stands for speed of light in vacuum, and V stands for speed of light in material. So how did we get this N equals C over V? We have this triangle here, all right? So we have C, we have V, and N. As you can see, N is equals to C over V. Now, it would be the same to find out the value of speed of light in material. So you would have V equals C over N. All right, don't get confused with that. Now, let's convert this, or let's find the value of this formula. So in the given index of refraction in our video, we have the water, we have the air, and we have this glass. All right. So the index of refraction of the water is 1.3. Air has 1.0, and glass has 2.4. Now, let's find out the speed of light in water, which has 1.3 index of refraction. Now, 1.3 equals C over V. What is the C? Standard speed of light in vacuum is 300,000 kilometers per second, or 3.0 times 10 to the power of 8 meters speed over V. But we are looking for speed of light in materials. So this is our formula, all right? So V equals C over N. Okay, we have 3.0 times 10 to the power of 8 meters speed over 1.3. Now, what is the answer? 3 over 1.3, we will have 2.307. But if you are going to round up into 2 decimal places, you would have 2.31 times. All right, so 1.3 has no units, so we will have 2.31 times to the power of 8 m meters speed. This is the value of your speed of light in material of water. Now, this is your activity for today. We have the given materials or medium, air, water, and glass with index of refraction. Earlier, we have already calculated the speed of light of water, which is 2.31 by 10 to the power of 8 ms or meter speed. Now, I want you to find the speed in the material or medium of air and glass. Compare the speed of light in water and air. Now, is water faster or slower than air? Which medium or material is the speed of light fastest and the slowest? Write your computation and answers on the paper. Take a photo, send it in private in line. All right? Thank you so much. Hope to see you again on our next video lesson.